Are you ready to roll? Thumbs up. Okay. So we are Green River Community College. We are fully suspended, and we're going to present to you our design project. This thing has taken about probably 8 months of our lives, and it's been an excellent experiment. So I'm David Schiff.
I'm Ian Smith.
I'm Jordan Smith.
And I'm Nick Outlaw.
And Jordan's going to take it away and kind of give you some background, inspiration on why we built what we built and why it looks kind of cool and sometimes kind of scary. So take it away, Jordan.
So we got our inspiration from Specialized Demo bike. It's an actual mountain bike design. And me and David were working in SolidWorks, and we got this idea from their bike. As you look at our SolidWorks design, it's very similar to their design. We got as close as we could with cardboard instead of the aluminum that they use. And so we had to blow up all the dimensions to make it to where it wouldn't explode, because we couldn't have stuff that's an inch around where it's made out of cardboard. So we had to come up with how to get this thing to work and make it be out of cardboard. And our goal, our original goal was, how can we make this as close to a real bike's dimensions as possible? Because we see all these huge bikes, and if you looked in our stock room, we have all four of the generations of the bikes, and the first bike's like this tall, and then the second one's this tall, and the third one's this, and so we wanted to keep going and get the design better every year. And so our criteria was to minimize weight, and we used that with laminated cardboard. We did use different materials to use different strengths on different parts of the bike, and integrate the difference between metal parts and wood parts. And to do that, we used this process with SolidWorks. And so we originally came up with our original design was all in SolidWorks, and we just started adding a little bit every week until we got to the actual competition and got all of our real information.
Yeah, so once we spent probably way too much time with SolidWorks, but we had a class, so kind of multitask. But we modeled every single bolt, nut, and screw on the bike, which may sound like a lot of work, but hey, SolidWorks, we have infinite amount of workspace, so why not test it and put it in there and see what's not going to work? So we put it in there, and it allowed us to, when we first put it in, we had like our rear sprocket was right here, and we put our front sprocket, it was over there, and our chain line was like 30 degrees. We're like, uh-oh, that's a bad problem. So it allowed us to look at a whole bunch of things, like for pivot locations, we were able to put geometries and test our suspension linkage. Like we first cycled it, and that red rocker, that thing hit like within a quarter inch of rotation. It was bottomed out. So we checked for all our components, make sure they had cycled through our travel and everything. And the suspension design we used is a horse link pivot. So that's this dude down here. And the beauty of it is, this part here, this is your seat stay. With that pivot there, it isolates your brake caliper completely from your suspension. So you can brake whatever you want to like the braking system, and your suspension is going to remain unaffected by those forces resisting the rotation of the disc. And so the other thing we had, it's obviously full suspension. So you can't be like, I'm going to build a full suspension bike and it's going to be super easy. So there's two things we want to go. The rear shock, this is like number 5 rear shock. What we ended up doing is a 3-stage, it's super technical, 3-stage spring shock. So the first stage is we have this really kind of lightweight, longer spring that gives us this off the top. You know, like when you're first cycling, you want your suspension to be relatively active so it actually works. In the second stage, we put a heavy-duty spring rate, so like you're not going to blow through all your travel. It's once you get like in the middle, 30% sag, you're going to start really getting that 1/2 kx squared force back. It hooks a lot. In the third stage, we put a solid foam core in there, so that when we hit the end, we're not just going to blow through it and like destroy our friend, because that'd be very sad. So all these things are concentric, different spring types, and they're all packed in with probably way too much grease. But hey, grease is cool. So that's the rear shock. And then we went to the front forks. The front forks, last year we did air gliders, and those technically worked. Theoretically, they worked, but practically, they sucked. So we want to do something different. We had this idea of doing rubber bands, like slingshot bands, something like that, because you know, like wrist rockets, those have good power. So we ended up doing bands, and we don't have any graphics, but they started out, and they mount on your kind of lower crown and loop under the bottom of the fork stanchions, and then that allows your fork to cycle. So we used heavy-duty elastomer bands. We got snowshoes over Christmas, and they came with these awesome, like inch-wide, heavy-duty rubber bands. It was like, ha! We were going to use those for our bike. And so we have those down at the bottom of our stanchions. We put Nick, he has an amazing idea. We were struggling with what to do with bushings. He came with the idea of doing these, like pretty much, we call them linear straight bushings. They go up pretty much most of the inner stanchion, and they give us stiffness in the front direction and the left to right direction. And then once we had all our SolidWorks, it's like, awesome, we got this model here. We can play with it and test it. So we did a whole bunch of finite element analysis on various elements. We weren't able to figure out the exact forces that were going to be going on just because I haven't taken dynamics and there's a lot of stuff with the linkage, but we were able to put a heavy amount of force on there and run through our frames and see what's going to break, where the stresses are. We want our factor safety of 1.8 so we could put force on all these and it's like, oh, that's going to fail, we need to fix that. So we did all those on pretty much every single part, including our drivetrain, transfer torque, and did all that. So I'm going to turn it over to Ian. He's going to tell you about our raw materials and what we did with construction.
All right, so our materials, we had 3 different types of paper product. We had the low density, non-water treated, the medium density water treated, and the corrugated cardboard. And then we had to use aluminum and glue to hold it together. What we did to hold it together is we would go 1 layer of paperboard, glue, another layer of cardboard, glue, layer of paperboard, glue, cardboard, glue, so on. And then we put a bunch of weight on it to hold it together, as you can see here. Just hold it together, let it dry. And we cut our frame out of that. And then after we had the frame, we covered it in glue and let that dry to make it more rigid and keep it from delaminating.
All right, so I'm going to talk about the assembly. So after we had spent several weeks going through, designing, building, tweaking, and we actually got to cut out our pieces, we had the task of putting a bunch of almost accurate cardboard pieces together and hope that they functioned properly and cycled as they should. So the first thing we did, as you can see over here, we had our main frame and we used just some random steel rods and stuff we had throughout the shop, and we kind of mocked that up just to see how it would cycle to make sure everything worked. And so as we worked, we would mark things and tweak little rods, and we were constantly, at this point the Dremel got to work out. We had 1 Dremel, and eventually we had 2 Dremels, and we went through countless bits, tweaking, sanding, and just all sorts of stuff. We also, as we were doing it, we ran into problems. Back here, our original design was to be smooth. We had to add, bracing. We just found that the cardboard, when we put weight on it, was too weak. Wanted to delaminate. Another issue we ran into was trying to figure out a chain tensioner. With the full suspension, you can't have the chain set tight when there's no weight on it, and then when there is weight, it needs to be able to stretch and take up that tension. So that took quite a bit of effort to figure out the best way to go about doing it, but we finally got a solution we liked. We also used a disc brake. You can't see it in this picture, but we ran the cable, a traditional bike cable through, and we came up with a paper lever. It's actually, the way we were able to design it, it's just slid onto the end of our handlebar. There's actually no attachment, and based on the angle it's cut at, it will return itself to the natural position with the tension. It was a tough task to get everything done, but we were pretty happy with the outcome so far, and we would like to thank some of our sponsors, Green River and Sunoco, for all our paper products.
1 minute.
Zach, any questions about any of the craziness or how we actually did this? It's not flammable, but just Zach, any questions you have for us? We'd love to attempt to answer them. Yes.
How do you make wheels so thin that are still able to support weight?
Very, very carefully. But we started out, you start with a square. You gotta go like a circular saw. Then you make it pentagon, octagon. You just keep chopping off sides.
Mm-hmm.
And then we compress these really hard. But after when it's just a plain cardboard, they tend to delaminate. So that's where the glue coating process Ian talked about, that really, there's probably like 2 layers of glue on there, which really lets stuff hold it together. So, yeah, back
Is
there.
it flammable?
No, we've actually tried. We've actually stuck it in the furnace when no one was, well, Janet was there, but it just starts to smoke. Like, 1,000 degrees Fahrenheit, it starts to smell really bad in ground, but it doesn't catch fire. So
Did you guys test the density of the frame?
yes. So that's what all three layers are.
And I needed to announce the density check will be done after lunch, that's what they told me to tell everyone.
Yeah.
Do you think that maybe, there was a famous race car designer, and he said that the optimum race car transmission is the one that blows apart when you cross the finish line.
That might be this.
The idea being that you don't make it any more than what the design requirement asks for.
Yeah.
And I'm looking at this and going, this is really cool, but do you really need all that to go 1.5 times around the track?
Well, in the years past, we've done a bike. That's not a challenge for us anymore. If you're not, as an engineer, if you're not pushing stuff, guess what? You're going to be replacing something. So it's like we built the hardtail last year. Okay, we can build a hardtail again, but we already know how to do that. It's like we're going to need more stuff in class. How are we going to apply to actually use that? So that's what I did.
Yeah.
It's a challenge.
We just wanted to push the limits of what we could do and hopefully still be competitive while doing it.
Yeah, that's why we have
That's our main
airplanes.
goal.
If we didn't push, we wouldn't have airplanes. So
And how come that one spot isn't green?
you liked it orange. Let's just kind of revolutions as we go into like revolution. You can find an RPM, you can find our torque, and our gear ratios. So yeah, that's what it's like.
Have you guys come up with the ratcheting wheel?
Really straightforward, standard BMX ratchet. You got Senior Cycle, $30. Just the Dicta, whatever, that's the brand that makes it. 16 tooth, has the ratchet inside, 30 OD threads. Just thread it onto an axle. That was the thing we had last year, and we're like, oh, they make those manufactured. We'll just buy one and screw it on. So, yeah. back
Are
there.
you all planning to be engineers?
Yes. So I'm doing mechanical.
I'm doing mechanical.
Yeah, goal.
Mechanical.
Before Mickey's up here.
So David, what kind of tool did you use for the mechanical
We use SolidWorks. Like what tools or like?
tools?
Yeah, just element analysis in SolidWorks. So there's a simulation tab. You go there. The only bummer with that is we can't do full assemblies because we have a student version and it won't allow us to do all assemblies. So that's why those picks are just the main frame, which makes it really hard because you got to find the reaction forces at each pivot and do that. So we want a professional version next year so we can actually load everything correctly.
So you are saying that at some point we have to see this safety factor is 1.8.
Yes, that's the minimum. That's like on the wheels. So if we're side loading the wheels at like, I think it's a 23-degree angle, that's when the wheels are going to fail, right at that inner radius of the spoke. That's a 1.8 safety factor. That's where it'll fail. So.
Excellent.